So I'm actually recording this. Feel free to stop me. It's okay. I could always go back and re-record whatever I need to do. So we're doing section 4.4. This is the last section of unit 4. We're going to have a unit test after we get really good at this section of dealing with parallel and perpendicular lines. But before we begin parallel and perpendicular lines, what I would like to do is just go back and review what we've learned so far in unit 1. In unit 4. In sections 4.1 to 4.3, we've covered slope formula. We've covered different forms of equations like standard form, slope-intercept form, and point-slope form. And I have like these like condensed notes right here that you have on your paper. And on these notes, it's set up to let you know how to write an equation in any form if I give you 2 points. All right, so if I give you 2 points, like I tell you, there's a line that passes through 2 points. Step 1 is to label your points x1, y1, x2, y2, and then you find the slope using the formula. And then once you find your m value using the formula, then you could take the point that they gave you originally and the slope that you just found to be able to plug it into point slope form. Y minus y1 equals m parentheses x minus x1. And then once you have it in point slope form, you could change it to easily to slope intercept or standard. You would have to get rid of the parentheses. So whatever number's out here, you'd have to distribute. That way the parentheses would disappear. And let's say they did want it in slope intercept form. You would get the y by itself by doing the opposite of whatever number is added or subtracted right here. Instead of me just explaining it hypothetically without an actual problem, let's all jot this question down right here. Write the standard form equation of the line that passes through the points negative 2, 3, and 5, 7. Okay, jot that down in your notebooks. I'm going to pause it here while you guys copy down that problem. So, step 1, as you can read right here, it says label your coordinates x1, y1, and find the slope using the slope formula. So that's what I'm going to do. I'm going to zoom in here. I'm going to label it x1, y1. This is my first point, my x value and my y value for my first point. This is my second point, so I put x2, y2. That's my x and y value for my second point. All right, I labeled it, and I also want to use this slope formula. Let me highlight it for you. M equals the division, the subtractions, and then you have your points, the y1 value, the y2 value, the x2, and the x1. We're going to use that formula, and whenever I use that formula, I always rewrite it with the division and the subtractions first, and then I plug in the values y2 and y1, x2 and x1, and I recommend you do the same. So y2 is 7, y1 is 3, x2 is 5, y1 is negative 2. With the minus minus, you have to change to plus plus, and we will soon see that our slope, 7 take away 3 is 4, 5 plus 2 is 7. Our slope is 4/7. Okay, we found the slope. It's 4/7. Whoops. There you go. Now, what does this mean? That I could go to a graph and plot this point because I know it passes through this point and that one. I could go to this one, and then from that point, I could rise 4 and run 7, and I would have the graph of my line. I mean, that's an actual thing I could do. But they want the equations in all 3 forms. Actually, no, on this one, they want it in standard form, but we're going to ultimately possibly go through all 3 forms. But right now that I have a slope and some points, we're going to move on to point slope form. And that's exactly why these steps right here. Step 1, find your slope. Once you have your slope and you have some points, you go for point slope form, right? Y minus y1 equals m parentheses x minus x1. Okay. So what we need to know is that the point x1, y1, this, the point x1, y1, negative 2, 3, you're going to plug it in to right here, this x1 spot and that y1 spot. And then you're going to take the slope that we just found, the 4/7, and you're going to plug it right there where the m is at. Okay, so we're going to plug it into point slope form, and point slope form is y minus y1 equals m parentheses x minus x1. Notice that I put it with blank spots so we could easily pop those values right in there. So my y1 value is 3. My x1 value is negative 2. My m value is what I found with the slope formula, 4/7. So that's my point slope form equation. The only thing I could do to make it look a little nicer is change the minus minus to plus plus. And if the question said write it in point slope form, this would be my answer. But it says standard form, okay? So standard form is down here, ax plus by equals c. Now, it doesn't matter if they said standard form or slope-intercept. Either one of those does not have the parentheses that point-slope form has. So you need to get rid of those parentheses. How are we going to get rid of these parentheses here? By distributing, right? So we're going to distribute the 4/7. Now, some of us are thinking, man, distribute 4/7. That's not going to be fun. Not only that, if they are asking for standard form, we don't want what? We don't want fractions, right? So if you have a fraction, you might as well get rid of it now because you want it in standard form. Does that make sense? So it's a lot easier, instead of distributing the actual fraction 4/7, to get rid of the fraction by multiplying everything by the denominator of the fraction that you want to get rid of. So again, we're going to multiply everything by what? 7, because that's a denominator. So I'm going to multiply the 4/7 times 7, and that will cancel out. I want to multiply the 3 times 7, and I want to multiply the y times 7. I'll multiply everything by 7. Now you're probably thinking, wait a minute, you said everything, but you didn't multiply the x or the 2 by 7. No, the thing is this, whatever I do to this fraction in front of the parentheses, it's like if I did it to the inside, because of the distributive property that's going to happen. Whether I like it or not, there's distributive property right there. Okay, so whatever I do to this guy, it's like doing it to these guys. So that's why I do not mess with the x or the 2. I don't multiply x by 7 or 2 by 7. Only this fraction by 7. Because whatever I do to this fraction, it's like if I did it to those inside guys because of distributive property. Anyways, we are getting rid of the fraction. We now have 7y minus 21 equals, there's a 4 right there, and then we have the parenthesis and the x plus 2. And now it's really easy to get rid of those parentheses because you're not distributing a fraction, you're distributing a nice number 4. So when we distribute, 4 times x is 4x, 4 times 2 is 8. Bring down the equal sign, bring down the 7y and the minus 21, and there's your new equation without parentheses. So right here they are asking for standard form, but it's just as easy if they would have asked for slope-intercept. Like slope-intercept is to get y by itself, so you would want to get this y by itself. If you wanted it in slope-intercept, you would have to get rid of that minus 21 by adding 21, and when you do to one side, do to the other, add 21, and you will have 7y equals 4x plus 29. And if you wanted to get the y by itself, all you'd have to do is divide everything by 7, and it would be in slope-intercept form. However, they're asking for standard form, and it's as easy as, we already moved the number to the right side. Let's move that 4x to the left side by getting rid of it by subtracting 4x and subtracting 4x, which you can't really do, so you're just going to rewrite it. Negative 4, it's an ugly 4, negative 4x plus 7y equals 29. That is my standard form equation, and that's what they asked for. Let's say you were taking a multiple choice test and you didn't see that exact equation in the multiple choice answers. They may have written it as a positive 4x with a negative 7y equaling a negative 29. So either one's totally fine. I like this one, but if it's in multiple choice and it's not there, it might have all the signs changed. Do we get it? Okay, now that is not an easy problem. That's a pretty long, lengthy problem, and it really does involve everything that we need to know from Unit 4. It involves the slope formula, it involves point slope form, it involves standard form, slope-intercept form, right? It has everything. So that's the majority of your Unit 4 test. There's only a new piece that's going to be added on to the test, which is parallel and perpendicular lines, okay? So what are parallel lines? Anybody? What are parallel lines? Yeah, you guys are doing the lines that are not crossing each other, right? Okay, so if I show you an actual example of that, those are parallel lines right there. Parallel lines. They do not cross each other, right? They're forever going in the same direction. So if they're going in the same direction, if you're talking about a graph, then you're talking that they have the same steepness. And if they have the same steepness, then they have the same what? Slope. That's exactly right, okay? So I could, if I wanted to, like find the slope of this first line, maybe from this nice point, from left to right to the next one, which would be right there on the y-intercept, right? I could do that. And my slope is down 1, 2, 3 over 1, 2. So my slope is, on this equation, m equals negative 2, negative 3 over 2. Okay, down 3 over 2. And this one over here, the slope on this one, if I pick nice points, like I want to pick this nice point up here, and then the next nice point is where it's right there. So I'm going to put a dot right there. And if I find the slope of these two dots, goes down 1, 2, 3 over 1, 2. It's the same exact slope, okay? M equals -3 over 2. So again, parallel lines do not cross. That means they're going in the same direction. That means they have the same steepness. That means they have the same exact slope. And that's the one thing that we need to learn, one of the two things that we need to learn today, that parallel lines have same slope, have the same M values, okay? Now, perpendicular lines, anybody remember perpendicular from previous grades? What does perpendicular mean? Yeah, some of you guys are drawing lines that are showing me fingers where lines cross. And that's exactly right. But to be more specific, perpendicular lines, they cross perfectly to form a 90-degree angle. And in geometry, that's very important, right? Because we're going to be, in geometry, you're going to be dealing with measurements of angles and stuff. So perpendicular lines, they cross each other and they form perfect 90-degree angles, perfect corners. However, in algebra, we're dealing more with the algebraic side. And what could we see about this equation, that the equation's y equals 3x minus 1, that's slope-intercept form, and this other equation, that's y equals -1/3 x minus 2. Anybody notice anything? These m values are the same, but when I look at this y equals mx plus b and that y equals mx plus b, are these m values the same? Heck no. And if we zoom in, we see that this m value is 3 and this m value is -1/3. And that's not coincidence. Anytime you have a perfect 90-degree angle, anytime the lines are perpendicular, your slopes will be opposite reciprocals of each other, okay? Opposite reciprocals of each other. If this is a 3, a +3, the other one has to have a slope that's opposite, which is negative, and the 3 over 1 gets flipped and it becomes 1 over 3, okay? Or the perpendicular slope of this guy, you change the negative to a positive and you flip the fraction and it becomes +3. So once again, perpendicular lines, and let's actually jot that down in our notes, perpendicular lines have opposite reciprocal slopes. What the heck does opposite reciprocal mean? It means that you have to change the sign, then flip fraction. Okay? So the two things that you need to learn today are that parallel lines have the same slope, perpendicular lines have opposite reciprocal slope, which means that you change the sign and flip the fraction. Okay? And that's the lesson for the entire day. However, we do have some notes. So on this page of notes, we already went through this review of the previous sections. And let's jump right into the actual notes that are printed out for you. You already copied this down, but let's read it again right here on the printed out notes. Parallel lines never intersect. They never cross. They're going in the same direction, which means they have the same slope. That's what you need to memorize today. Parallel lines have the same slope. So all of these examples down here are examples of lines that have parallel, or that are parallel, which means they have the same slope, right? So if you take a look at the first equation, y equals mx plus b, y equals mx plus b, these two lines are parallel. I could tell that they're never going to cross. Even though I'm not seeing the line graphed on an xy plane, I could tell they're never going to cross because they have the same slope, 2/3 and 2/3, right? So first thing to understand is you could only see the m value if it's in either point slope form, right there you could see the m value, or slope intercept form, right there you could see the m value. If it's not in one of these forms, you're going to have to change it to make it look like either point slope or slope intercept so you could actually see the m values. So all of these right here are just examples of equations that are parallel, right? All of these have the same slope. Look, this one's in point slope form, that one's in point slope form. This slope is 1/2, the m value is in front of the parenthesis. This slope is 1/2, the m value is in front of the parenthesis, right? Now, if you're thinking, wait a minute, this slope is -2 and this one's not -2. Well, the thing is, in order for you to identify m, like right here, you could see that m is -2. Why? Because it has y by itself. Y equals mx plus b. You could see that the m is -2. The slope is -2. Over here, this is not the slope, not yet. Why not? Because the y is not by itself. So you may have to manipulate an equation to get it either in slope-intercept form or point-slope form so you could clearly see the slope. So if I did want to change that negative y to a positive y, I'd have to multiply everything by -1. In other words, change all the signs, and then it'll be y equals -2x minus 4. And then you could be like, oh, my slope here is -2. So now you could compare that -2 with this -2, and yeah, they're the same slope. They are parallel, okay? So these are examples of parallel lines. This last one, again, you can't see the slope yet. What would I have to do to see the slope? Anybody? Divide by 2. All right, so if you divide it by 2, divide by 2, divide by 2, you're going to get an equation y equals 1/2 x minus 7. And there's your slope-intercept form equation. And now you could be like, okay, my slope on the slope-intercept form equation is 1/2. And over here, my slope on the point-slope form equation is 1/2. So yes, they are parallel. They have the same slope. So these are all examples of them being parallel. Up here, we have our notes that say perpendicular lines intersect each other to form 90-degree angles. They form perfect corners. But more importantly, perpendicular lines have opposite reciprocal m values, opposite reciprocal slopes. What does that mean? That there's a change in the sign and then you flip the fraction, okay? So imagine if I just looked at this slope right here, 2/3, and if I were to change the sign and flip the fraction, what do I end up with? I end up with -3/2. So that's why these lines are perpendicular. And I know they're perpendicular. Let me erase the highlighter, kind of looks ugly. I know they're perpendicular, even though I haven't seen the graph on the XY plane. I know they're perpendicular because this slope and that slope are opposite reciprocals of each other. The 2/3, if you change to a negative and then flip it, it'll say -3/2. Because they're opposite reciprocal slopes, I know that they're perpendicular, right? And of course, you may have to change an equation to be able to see the m value, okay? So for example, number 4, what's the slope on the first equation? The slope is what? On the first equation over here, what's the slope? The m is in front of the parenthesis. The slope is 3/2, yay? Okay. Now, this one has to be perpendicular. What is the perpendicular slope? If this slope is 3/2, what's the perpendicular slope? You change the sign and flip the fraction. So what would that be? -2/3. So I need to have a slope of -2/3. As you can see, the y is not by itself. I need to get y by itself. I need to get rid of that -3 by by dividing by -3 to get rid of that multiplication of -3 in front of the y. Divide everything by -3, and then you'll have your new slope-intercept form equation, y equals -2/3 x plus 4. And now you could see that the slope is -2/3, which happens to be the opposite reciprocal of that slope over there. That's why they're perpendicular. So that's the entire lesson right there. Let's review what it says right here. It says, the important detail when deciding whether lines are perpendicular or parallel or neither is that you must have the equation written in either y equals mx plus b or y minus y1 equals m parentheses x minus x1. They have to be either in slope-intercept form or point-slope form in order for you to be able to see those m values. And then when you're able to see the m values, if they're the same exact m value, you're going to say that they're parallel. If they are opposite reciprocal m values, you're going to say they're perpendicular. And if they're just like totally different and they're not opposite reciprocal, then you would just say neither. And those will be actual questions on next week's test, all right? And they actually come out on the final exam also. So here's the actual type of question you're going to see on next week's test. I give you 2 equations, and I ask you, are these parallel, perpendicular, or neither? So if you look at this equation that's in slope-intercept form, and this equation that's in slope-intercept form, are they parallel? Is this slope identical to that slope? No, so they are not parallel. Are they perpendicular? Well, in order for them to be perpendicular, you have to have a sign change, which would be a negative, and you have to flip the fraction, which would be a 2 over 1. So is this slope over here negative 2 over 1? Yes, it is. Even though it's not over 1, I mean, you could make it over 1, just put a 1 underneath it. And those are opposite reciprocal slopes. So on number 1, you would say perpendicular. Please write that down. Okay. Number 2, well, could I see the slope of either of these? Do I know the slope of the first one? Not yet, because I need to get the y by itself. I need to make it be y equals mx plus b in order to be able to see the m in front of the x. So right here, it's not y equals. It says negative 3 times y. So what am I going to do to get rid of that negative 3? Divide by negative 3, divide by negative 3, divide by negative 3. So remember that there's an invisible 1 right there in front of the x. So what we have here is y equals a negative divided by a negative is a positive. So that's going to be a positive 1/3 with an x. And then negative divided by a negative is a positive. And 8 divided by 3 you can't do. Just write it. Who cares? Because the only thing we really care about is the slope, right? So right here, the slope is 1/3. On the other one, the slope is what? 3/2. So they're definitely not the same. You're not going to say parallel. They're definitely not opposite reciprocals. The opposite reciprocal slope of negative 1/3 would be negative 3, and that's not negative 3. So this would be one of those examples that's neither, right? So you would say neither parallel nor perpendicular. So that's number 2. And these are the type of questions you're going to see on the test next week. Maybe about 3, 4, maybe 5 of these, right? So it's really easy to do. All you got to do is make sure you could identify the m value, okay? Anyway, number 3, this is in standard form, ax plus by equals c. And in standard form, there is no m. So you can't see the m value here. You would have to do some work to get m by itself. To get y by itself so you could identify m. So on this one that's in standard form, you have to change the slope-intercept by subtracting 2x, subtracting 2x. You'd have 3y equals negative 2x plus 12. For your final step, you would divide by 3, divide by 3, divide by 3, giving you y equals, the slope would be negative 2/3 with an x, and then plus 12 divided by 3 is 4. So we could clearly see that the slope of this standard form equation, once you change the slope-intercept, the slope is negative 2/3. So if the other one has the same exact slope, negative 2/3, then that would be a parallel line. If it's a positive 3/2, then that would be a perpendicular line. If it's neither, then it would be neither. So if we look over here, we still cannot see the slope over here because it's not y by itself yet. So I want to get that y by itself. I'm going to divide by 3, and divide by 3. So my equation would be y equals 2/3. That's an ugly 3. Oh, wait, hold on a second. 2/3 x plus 5 over 3. So when we look at this fraction, negative 2/3, and that fraction, positive 2/3, are they identical to each other? No. One's negative, one's positive. So they're not parallel. Are they opposite reciprocal? Well, they're opposite, but they're not reciprocal. There is a sign change. This one's negative, this one's positive, but it didn't flip. It should have been 3/2 in order for it to be perpendicular. So this is another example of neither. Does that make sense? So everybody should label this one neither. Okay. So that's going to be some type of question that we will be having. I'm going to skip the rest and jump to the worksheet that's on the back side. On this back side, if you look at the middle section, they keep going with that. Determine whether any of the graphs of the lines are parallel, perpendicular, right? So first, you got to make sure that they're in slope-intercept form or point-slope form for you to be able to see the m. See that first equation, you could see that the m is 2/3. The second equation, the m is 3/2. This third equation, it's in standard form. So you're going to have to mess with it to get y by itself so you could see m. So when you do get y by itself, if your m, once you get y by itself, if your m is 2/3, then you would circle that one and this one and say that they're parallel. Or let's say that when you get y by itself, you'll be able to see m. And if the m is negative 2/3, then it would be the opposite reciprocal of this one. So you'd circle that one and put perpendicular. You get the idea? I hope so. Now, the rest of this worksheet is really easy if you understand parallel and perpendicular. Let's read the instructions. It says, write an equation in slope-intercept form, so you want y equals mx plus b, of the line that passes through the given point and is parallel to the graph of the given equation. So they're giving you a point, and they're telling you that your equation that you want to write is going to be parallel. Okay, it says right here, let me zoom in. It's going to be parallel to the given equation that they give you. So what does parallel mean? It means what? Same slope, same m value. So if you want, circle parallel and put same m. You see, when they tell you that your line is parallel to this given line right here, that here's a line right here, they give you a point and they tell you your line is going to cross right through here and it has to be parallel to this one. Technically, they are giving you a point and a slope, right? They're giving you the x1, y1 of negative 2, 2, and they're indirectly giving you the slope, which has to be the same exact slope as this one, because they're telling you that yours is parallel to this one. So this slope is 1/2. That means that your slope is 1/2, okay? So how would we write an equation in slope-intercept form if we know a point of our line and the slope of our line? They gave us a slope indirectly, telling us that it's parallel. How would we do that? We would go with point-slope form, which is y minus y1 equals m parentheses x minus x1. When you use the point-slope form, I recommend rewriting it with blank spots. Y minus y1 equals m parentheses x minus x1. And then plug in your x1, y1 values. The x1 value is negative 2. The y1 value is 2. And the m, since they told us it was parallel, we already know that our m is the same as that m, which is 1/2. And there's your point-slope form. The only thing you could do to make it look nicer is change the minus minus to plus plus. Now, they didn't ask for point-slope form. The instructions say write it in slope-intercept form, okay? But we at least have a form of an equation, which is point-slope. If you want to change the slope-intercept, get rid of the parentheses. How? By distributing the fraction. And this time it's pretty easy to distribute 1/2 times x. That's just 1/2 x. 1/2 times 2. What's half of 2? It's positive 1. And then bring down the equal sign, bring down the y minus 2. All you need to do now is get y by itself. To have it in slope-intercept form, you would add 2 and add 2, and that'll be y equals 1/2 x plus 3. We just found the slope-intercept form equation of a line that passes through the point negative 2, 2, and that is parallel to this line, which is telling us that it has the same slope. We did that algebraically. We could have done this a lot easier visually. Like we could have said, well, if I know my line's passing right through this point and it's going to be parallel to this one, that means that it has to be perfectly the same. It's not going to cross. It's going to have the same slope. So if I know my slope is 1/2, then from this point, I could go up 1/2 and put a dot right there. And I could continue to go up 1/2, put a dot right there, and I could actually draw my line like that. And that red line is definitely parallel to this black line. It's never going to cross because it has the same slope. And once you know that, well, you're like, oh, my b value is 1, 2, 3. My b value is 3, and my m value is 1/2. That must mean that this red line is the equation y equals 1/2 x plus 3 because it crosses the y-axis at 3. That's exactly the same equation we found algebraically as opposed to visually. Make sense? So if we look at the rest of this worksheet, they give you a point. They give you a point and they tell you that your line is parallel to this one. So indirectly, they're giving you a point, x1, y1, and indirectly they're telling you a slope. If your line is parallel to this one that they give you, then that is the slope. Your slope is 1/2. And once you know the slope, and once you have a point, you could go for point-slope form. And when you use point-slope form, go with blank spots and plug in the m value, that is 1/2. How did I get that m value? Because they told me my line is parallel to this one. Now, if they would have said my line's perpendicular to this one, then I would get my slope as a negative 2/1. So my slope would be negative 2 if they would have said perpendicular. That's the second half of the worksheet. Right now it's saying parallel, which is the same exact slope. Now the y1 value is 3. So we put the 3 right here. The x1 value is negative 4. And of course, change to plus plus. And they are asking for a slope-intercept form. So you got to get rid of these parentheses. How? By distributing 1/2. Now, if it were a crazy fraction, like let's say 5/7, I'd get rid of the denominator by multiplying everything by the denominator. But 1/2, everybody could probably do 1/2 of x, right? 1/2 times x is exactly 1/2 x. 1/2 of +4 is +2. Really simple to distribute 1/2. Bring down the y minus 3. And then you want to get y by itself. You add 3, add 3. Your slope-intercept form equations, y equals 1/2 x plus 5. That's your answer for number 9, okay? And again, that's a whole first half of the worksheet where they say they give you a point and your line is parallel to that one, which means it's the same slope. Down here on the second half of the worksheet, they give you a point and they tell you that your line is perpendicular. So what does that mean, perpendicular? You're going to have opposite reciprocal slopes. What does that mean? Change the sign and flip the fraction, okay? So they give you a point and they give you a slope indirectly. Now, number 15 is probably the most interesting one of them all because the point that they give you, the x1, y1 is right there, but the slope, you can't see the slope yet because it's in standard form, ax plus by equals c. You don't want it in standard form. You got to either go with slope-intercept or point slope. Slope-intercept is the easiest. Get y by itself. Subtract x, rewrite it. 3y equals 6 minus x. Actually, I should have, not 6 minus x, negative x plus 6. That's better. And then get rid of the 3 by dividing by 3, dividing by 3, dividing by 3, recognizing that there's a negative 1 in front of the x. You will be able to see your final slope-intercept form equation. Y equals negative 1/3 x plus 2. So what I've done so far is just change this standard form. I changed it to slope-intercept form. Why did I do that? Just to be able to identify the m value of that original equation. Now, if that m value is negative 1/3, what is our m value going to be, knowing that our line is perpendicular to this line? Not parallel, but perpendicular. What's our slope going to be? Anybody? Yep. Change the sign, flip the fraction. That would be a +3. Thank you so much. So m is +3. After that, you don't need to look at this. You don't need to look at this again, right? You pulled out the information that you wanted. Our slope, the opposite reciprocal of that slope. Our slope is m equals 3. And now we have a point and a slope, and now we could jump to point slope form, which is y minus y1 equals m parenthesis x minus x1. And again, when you use it, use blank spots. Y minus y1 equals m parenthesis x minus x1. Plug in your x1 value, which is negative 1, your y1 value, which is negative 6, your m value, which we found out was 3 because it's perpendicular to this guy, which is opposite reciprocal. And then you could change it to a plus plus and rewrite it in slope-intercept form. They want y by itself. They don't want parentheses. How do you get rid of these parentheses right here? Come on, guys, we're almost done. How do we get rid of those parentheses? Distribute, okay, 3 times x, 3x. 3 times 1 is +3. Bring down the equal sign, bring down the y plus 6. Final step would be to subtract 6, giving you your final equation, y equals 3x minus 3. There is the equation that passes through this point that if I were to graph it would be perpendicular to this equation over here. There's your answer, y equals 3x minus 3. Guys, I hope this lesson helps. It was a long one, but I don't think it's a challenging one. I think all we need to do is practice our skills on changing equations from standard to slope-intercept, identifying the m value, and learning what we learned today, that the m, if they're the same, they're parallel. If they're opposite reciprocal slopes, they're perpendicular.